Hi students, welcome back. Let's continue with our transport layer protocol in ad hoc wireless networks. So coming to the next topic, that is a classification of transport layer solutions. So in the previous video I explained that why the TCP will not supporting the it does not performing well in ad hoc wireless networks. Okay, so to overcome those problems, the transport layer solutions for ad hoc wireless networks are introduced. So now let's see what are the different protocols that we are using for transport layer solutions for ad hoc wireless network. So the transport layer solution for ad hoc wireless networks is of two types. One is the TCP over ad hoc wireless network, the TCP over ad hoc wireless networks, and other transport layer protocols. The TCP over ad hoc wireless is of two types. One is a split approach and another is an end-to-end approach. And these are all the different examples for that. So now let's discuss one by one each example. So first we'll know about the TCP over ad hoc wireless networks. The TCP over ad hoc wireless network, here the TCP is a reliable end-to-end connection-oriented transport layer protocol that provides a byte stream based service. So we already know that the TCP is reliable, end-to-end and the connection oriented. What are the major responsibilities of this TCP? The major responsibilities are congestion control. It has to be take care about the congestion control whenever the packets are when the buffer is full. Flow control, in order delivery of packets, reliable transportation of the packets. So these are all the responsibilities of the TCP. Okay, so now let's see what are the TCP over ad hoc wireless network protocols are. So the protocols are divided into two types, end-to-end approach and split approach. Now let's see the first example in the end-to-end approach, TCP F. So what is this TCP F? Here the F is nothing but the feedback. Just remember, F is a feedback, the feedback TCP. So what is the use of this feedback TCP? The feedback TCP improves the performance of the TCP, uses a feedback based approach. The routing protocol is expected to repair the broken path within a reasonable time period. So what is the main use of this feedback protocol? What it is doing, it's just like a handshaking. So whenever you are giving something to you, you're just responding to me. Okay, whenever I say hi, you're replying to a hello. So here it uses a feedback based approach. This protocol uses a feedback based approach. Here the routing protocol is expected to repair. So suppose whenever I want to send a message A to B, suppose the link is broken. So here what is the routing protocol has to do in the feedback TCP? The routing protocol is expected to repair the broken link path within a reasonable time. Okay, within reasonable time it has to be repaired and again it has to send the packet. So that is the main use of this feedback TCP. Let's see the operation of this feedback TCP. So how it is going to be work. First let me, I had already written the notes here. Okay, if you are having any doubts, just make a pause and make a note everything. Okay, so operation example I am explaining for each and every protocol. So first let me read out of this and I'll explain each and every point in the when I am explaining the diagram. So in the TCP feedback, an intermediate node upon detection of a path break, suppose let us take here one node is there, another node is there, in between an intermediate node is there. So let's take this is an intermediate node. Okay, so here the TCP feedback, an intermediate node upon a detection of a path break. So let us take the intermediate node detects a path break. It originates root failure notification. So how it is going to originate the path break? By root failure notation. So it is sending to the sender and the receiver. It's sending the root failure notation. So this is an intermediate node. The intermediate node is going to originates a root failure notation packet. So this intermediate node is called the failure point. So this is the failure point. The intermediate node is called the failure point. So from that point only the node was not reached the destination. So that point, that intermediate node is the failure point. So this root failure, R means root, F means failure, root failure notification is routed towards the sender. So it is routed towards the sender of the TCP session. Sender information that is obtained from the TCP packet. Suppose if any intermediate node that receives the RFN, let us take this, any intermediate node that receives the root failure notification has an alternate route to the same destination. Let us take, so this is one destination and another route. So different routes are there for the same destination. Let us think, there are different routes for the same destination. If this intermediate node, don't be confused, if this intermediate node receives RFN, let us take it receives root failure notification, has an alternative route and the same destination, to the same destination, let us take this is one path and this is another path. So then what it does, okay, so whenever it so alternate route to the same destination, then it discards the RFN. So it just discards the RFN packets and uses the alternate path for forwarding further data packets. So rather than going back, it just takes another route and sends the packets to that route. Okay, so then it discards the root failure notification packet, which node? Intermediate node, and uses the alternate path for forwarding the further data packets, thus reducing the control overheads involved in the route reconfiguration processes. So what is this use of this feedback TCP? So whenever the root notification failure is occurred at the failure point, if suppose the multiple paths are provided to the destination, so rather than going back, okay, it takes another route and reaches the destination. So if it follows that procedure, it what is the use of following that procedure? It reducing the control overhead which is involved in the route reconfiguration process. So see here, suppose when TCP sender receives an RFN packet, so this is the sender here and the receiver here. Suppose the TCP sender receives an RFN packet. It receives the RFN packet, root failure notification packet. What it does? It goes into a state called snooze. So whenever it sees the root failure notification, the sender is going to enter into the snooze state. So in this state, what the sender will do? The sender stops sending any more packets, means it is not sending any more packets to the destination, and cancels all timers. All timers are cancelled, freezes its congestion window, freezes the retransmission timer, set up a root failure timer, everything becomes ideal. Whenever the sender receives the root failure notification packet, the sender is going to be snooze. Suppose when root failure timer expires, the TCP sender changes from snooze state to connected state. So whenever suppose is a root failure timer is expires, the TCP sender changes its snooze state to connected state. When root re-establishment has been done, then the failure point sends root re-establishment notification. Root re-establishment. After the snooze state, the sender becomes the connected states. Then what it does? It sends to the failure point, means the intermediate node. To the intermediate node, it sends a root re-establishment notification. First, it sends a root failure notification. Next, it sends a root re-establishment notification packet to the sender, and the TCP state is updated back to the connected state. So see here the example. Suppose the TCP state connected, means it's a normal process. A to B, B to C, C to D. D is the destination. So TCP feedback connection from A to D. Now think, TCP state is snooze. So when it is snooze, whenever it receives the root re-establishment notifications here and at the C, so which is a failure point. Which is a failure point, intermediate node. Whenever it's break is done, it sends a root failure notification. Root failure notification to B. Then B will send the root. Okay, the root is failure, so you please re-establish the root notification to A. But A is in snooze. Here line CD breaks and C originate to RFN. Next, what it do? So after the timer is up, it is again root re-establishment notification will be sent. So whenever the TCP state is connected again, the C sends a root re-establishment notification and the B is also sends a root re-establishment notification. Then A will be again transmit the data and sends to the D. It's a rejoins. Link CD is rejoins. So this is how the operation will be established. Then in the case of feedback, let's see what are the advantages and disadvantages of using this feedback TCP. Advantages is simple feedback solution for problem arising from path breaks and permits the TCP congestion control mechanism to respond to the congestion in the network. Then what about the disadvantages? If a route to sender is not available at the failure point, let us take, if the route to sender is not available at the failure point, then additional control packet may need to be generated for routing route failure notification packet. So this is one of the disadvantage, because it has to again send the additional control packet need to be generated. And TCP feedback has an additional state compared to traditional TCP state mechanism. So these are the disadvantages of feedback TCP. Thank you.